Hi, we're back with derivatives of trigonometric functions. That's section 3.9. This is video number 2 for that section. And we're just starting to hit on the derivatives of trigonometrics. So, what you'll notice is that when you're doing your homework and you go to, for example, the help me solve it or the show me a similar problem, what you'll see is some identities. I've got one of them written up on the board here. So what an identity is, if you stay in calculus for very long, you'll end up with lots of tables of identities like this that tell you how to derive certain flavors of functions. And so this one says that the derivative with respect to x of arc cosine of u is equal to the derivative of u with respect to x divided by the square root of 1 minus u squared. And so this is problem number 6, and let's see, it wants us to take the derivative of the arc cosine of root 7t, so we're trying to take d dt of root 7, of cosine inverse of root 7t, and so what we're going to do here is we're going to figure out what goes where. And this is really important to be able to read charts and figure out where to plug things in at. So if this is arc cosine of u, and this is arc cosine of u, well then what does u equal? U has to equal, to follow our identity, it has to equal root 7 times t. And so now that we know that, we can move over to this side of the identity and find out what du dt is. And I'm sorry, up here I have this written as du dx, but in this problem they gave us t as the dependent variable, or as the independent variable, so we could replace the identity with du dt. You'll have to do that depending on what variable is being used. So du dt is root 7 times t, using the power rule, is just going to give us root 7. And so what we end up when we plug it in is this whole thing is equal to root 7 divided by the square root of 1 minus u squared, which is root 7t squared. Alright, and we can simplify it, but we're pretty much done here. It's just nothing but under the square root 7 divided by 1 minus 7t squared. And this is our answer, using this identity. Now, the second thing I wanted to do is walk you through how you can avoid, of course, on your tests, you don't have to memorize these. They'll be provided on a handout, like a cheat sheet. But sometimes it can be fun to know where they come from and how to solve these without needing a table. And so that's what I'll do next. Alright, so we're no longer using this identity up here, and we have the same problem. It's y equals arc cosine of root 7 times t. Alright, so we know how to take the derivatives of sine and cosines, but not of arc sines and arc cosines. So we can change an arc cosine into a cosine by moving it to the other side. So cosine of y equals root 7 times t. And I think I forgot to mention that last video is that, for example, if I have the arc cosine of cosine, I'm sorry about that, if I have the cosine of arc cosine of theta, that equals nothing but theta. So think of with multiplication, how do we undo that? In algebra we divide. If we've added something, how do we undo it algebraically? We subtract. If we have a cosine, we can algebraically manipulate it by creating an arc cosine and vice versa. So that's all that we're doing here, is we're saying that cosine inverse of root 7t equals y is equivalent to cosine y equals root 7t. Well, now the next step is we're going to use that implicit differentiation stuff. So implicit, I've got a video on that. If you haven't seen it yet, definitely go and watch it. So I'm going to take the derivative of both sides with respect to t. So d dt of both sides. The derivative of cosine is negative sine of y. But y is in and of itself a function of t. It's a dependent variable. T is the independent variable. So we've taken the derivative of the outer function. Now to respect the chain rule, we have to take the derivative of the inner function, which is y. And we want to take that derivative with respect to t. So negative sine y dy dt equals, what's the derivative of root 7 times t? Well, according to the power rule, it's just root 7. So we have root 7. Now we're going to go ahead and get our dy dt all by itself. And we'll do that by dividing over negative sine of y. So this equals root 7 over negative sine of y. You may be thinking, well, we don't have this in terms of just t. And you're right, but we can actually go back to our y up here and we can plug it in down here. So I can plug in my y up here into my y down in this equation and write it like this. dy dt equals root 7 over a negative sine of y equals arc cosine of root 7t. And now all that we need to do is what we did in the last video twice, which is to draw a triangle. So cosine we know is, cosine we know is going to be adjacent over hypotenuse. So if we look in here, we don't see a fraction, but you can always divide something by 1. So I'm going to put an imaginary 1 in there, and this will be the adjacent over the hypotenuse. So the hypotenuse is 1, and the adjacent is root 7 times t. And we need to solve for the opposite, because sine is opposite over hypotenuse. So how we can do that is we could label it x or something like that. And we know due to Pythagorean theorem that x squared plus, or I should say opposite squared plus adjacent squared is equal to hypotenuse squared. And what we end up with is x squared plus 7t squared equals 1. We'll subtract the 7t squared over. X squared equals 1 minus 7t squared. And then we're going to take the root of both sides. To get x all by himself, x equals 1 minus 7t squared. So if we know that the opposite, which equals x, equals this, then to fill in sine here, we have to do opposite over hypotenuse, because sine is opposite over hypotenuse ratio. So if we're looking at our triangle here, the opposite is x, which we solved here. So we've got opposite 1 minus 7t squared over hypotenuse, which is nothing but 1, so we're just dividing by 1. We still have a negative out in front here, and there's still a root 7 up here. And then we can simplify it down, all under one root. The square root of 7 divided by 1 minus 7t squared. And what you will notice is that this looks an awful lot like this. And so how this identity was derived was using implicit differentiation. If you prefer to use the identity, go ahead. It'll usually save some time. But if you want to figure out where it's coming from and brush up on your implicit differentiation skills, definitely practice a few of the problems this way. I hope this was helpful, and I'll see you next time.